Hi, in this video we're going to look at the operator module. Now we have functional equivalents to operators in the operator module. What does that mean? Well, think back to the last lecture where we wrote code such as the following, right? We had a list, let's say 2, 3, and 4, and then we called reduce on that list, and we wanted to find the multiplication of each of the elements. So we wanted to find 2 times 3 times 4. So we could use a reduce function. And of course, we needed to multiply a and b together. So we used the lambda expression to do that. And so this would have reduced back down to 2 times 3, 6 times 4 is 24. So we don't have to do that, however. We can use the operator module. The operator module was created to give us functional equivalents to a lot of the operators in Python, like for example, the multiplication operator. So instead of using our own lambda here, we can use a function that's defined in the operator module and pass that in as the function, instead of having to create our own function or a lambda. So it's really a convenience module, and of course you can always use your own functions and lambda expressions instead. You don't have to use what's in the operator module, but it's handy to have them around. So for example, let's see some functions that are available in the operator module. Well, we have a bunch of arithmetic functions, like for example, add. So instead of doing lambda a comma b colon a plus b, that would return the sum, you can just call add. You can pass in add, let's say, to a reduce function. And that will then add all the elements of that list. Or you can use mul for the multiplication operator. That will multiply a and b. You have also the power, a to the power of b. You have the modulus, a modulus b. You also have floor division, a / b. And you also have negation of a, which is a unary operator. It only takes a single argument, but it basically returns the negative of a. So these are some of the arithmetic functions available in the operator module, and many more. So you can always look at the documentation and see what's there. But if you're going to be using a lambda expression or a function that basically just takes an existing operator and rewrites it so that you can use it in a function, right, passing it as a function, because you can't pass an operator, you have to pass a function in a lot of these higher order functions, then look at the operator module. You most likely will have what you're looking for in there. Now, if it's more complicated, where you have more things that you're doing, then obviously not. But if it's really just equivalent to an operator, it's probably in the operator module. In fact, let's look at some more. We have the comparison and the Boolean operators as well that are available, like LT for less than. So this will test if A is less than B, right? That's equivalent, that's the functional equivalent to the less than operator. We also have less than or equal to. We also have greater than and greater than or equal to. We also have the equal operator. Now this is the equals equals operator, right? This is not the is. EQ is for A equals B. That's the functional equivalent. We also have not equals, right? A and B. So we also have the is, and now is a built-in name, right? So we can't use that. So what all that the operator module does, it basically redefines it using an underscore at the end. So it differentiates it from the built-in is function. But it basically will test A is B. And is not will test if A is not B. So just functional equivalents. And we also have functional equivalents for the main Boolean operators and, or, and not. These are all built in as well. Again, they have the underscore to differentiate them from the built-in operators in Python. We also have a bunch of sequence and mapping operators. So for example, you can concatenate two sequences or two strings using this concat, right? So it's the same thing as concatenating. We also have contains. This basically tests S in val. Value in S. This will test to see if the value is present in the sequence. Now we'll see that again when we look at sequence types in more detail. We'll look at the in operator in particular, but in this case, the contains is the functional equivalent of that in operator. We also have count of, where we can see how many times does val occur in S. This basically counts. You also are able to get items by index. So this get item s comma I will return the item at index I in S, assuming that S of course is large enough to retrieve that item. So this is the same thing as really saying S square bracket I, right? But this is now a functional equivalent of that operation. You also have the set item. Set item is going to set s, I, so s square bracket I equal to val. That's the equivalent expression. But now you have a functional equivalent if you need it. You can also have deletion. So you can delete items by index in some sequence S. Now, of course, set item and delete item will only work if S is a mutable object. So it's not going to work for tuples, but it will work just fine with lists. And you have variants that use slices as well. And we'll get to that later because we still have to look at slices in more detail when we get to sequence types. So we'll come back to this, and then we'll come back to the operator module and see what are the other equivalent functions that we have that allow us to do slicing. Let's take a look at the item getter function. Now, the item getter function is something that returns not a value, but it returns a callable. So what do I mean by that? Well, let's look at an example. Let's say that we create this. We say get item, and we pass in some sequence, and then an index value I. So it takes two parameters, right? So it's going to return the value s at I. That we just saw. That's what get item does. It returns the value. So if we take s equal to 1, 2, 3, we can say get item s comma 1. What is that going to return? That's going to return 2, right? The value at index 1. Now, item getter, on the other hand, you don't pass in the sequence. You just pass in the index that you're interested in. And what it does, essentially, think of it as a partial function. It's really the get item needs two things. It needs the sequence and it needs the index. Here, we're essentially creating a partial function that only takes the index. So now this is a callable, so it's going to be a function, but it's still expecting, it still needs the sequence itself. So item getter I is a callable, which takes a single parameter, the sequence object, right? The one that's missing. When we had get item, we had two parameters, s, right, and the index I. Here we only have I, so we still need to pass it the sequence. So for example, we can say f equals item getter 1. So what is this going to be? Well, this is going to be a function, a callable. F is now a callable that will take a single parameter, which will be a sequence object, and it will always return the second element of that sequence object, if it exists, no matter what the sequence is. So for example, if s is 1, 2, 3, then f of s will return 2. If s, on the other hand, is a string, also a sequence type, then f at s is going to return y, because that's the second element in the string. So you can see that item getter and get item are very related. There's a little bit of a difference here, though. Get item requires two arguments. Item getter only requires one argument, because it returns a callable, it returns a function. And now you can pass that in maybe to something that requests a function that only takes a single parameter. It's the same reason why we had partial functions. The same thing might be happening here. We'll get to some examples later on in the code video and also throughout the course. So continuing to item getters, we can actually use more than one index in item getter. So for example, let's say we have this list and we have this string. Now we can say f equals item getter 1, 3, 4. So it takes a variable number of arguments, of positional arguments. So we're saying that this callable is something that's going to return the elements at index 1, 3, and 4, and will return it in a tuple. So if we call f of L, we'll get 2, 4, and 5, because that's at position 1, 3, and 4. And if we do f of S, we'll get something very similar. We will get a tuple again, containing the elements at index 1, which is y, and then 3 and 4, h and o. So item getter can take more than one argument. And all it does, it just returns that tuple. Okay, so let's talk about attributes. Objects have attributes, right? Objects can have methods, they can have properties. All these are grouped under the generic name attributes. So attribute getter is similar to the item getter function, but it's used to retrieve object attributes. So it also returns a callable. Just like item getter, it's actually going to return a function. But that function will then take the object as its argument. So let's take a look at an example. Suppose my object is an object with three properties. Let's say it has properties A, B, and C. And maybe it's got a bunch of other ones. It's got methods as well, and so on. Let's focus on properties right now. and we know of 3, A, B, and C. A is 10, B is 20, and C is 30 for this particular instance, right? My object is an object, not a class, it's an instance. So now we set f equal to attribute getter A. So now this is a callable that's going to look at the attribute A, but it still needs the object, right? It doesn't know where it's going to get that attribute from. And this is why f is a callable. So now we can call f passing in my object. So it doesn't matter what the object is. If it has this attribute A, f of my object will return whatever A is. Either it's a value, if it's a property, or maybe it's a method, right? If it's an instance method. In this case, it will return 10 because we're looking for A. Similarly, attribute getter can take more than one positional parameter. So here we have, let's say, A and C. So we're looking for the properties A and C, right? The attributes A and C. So if we do that, we'll get a tuple that will contain 10 and 30, just like we had with item getter. The only difference is that here it's looking at attributes of an object. Now, of course, you can also call it directly, and the same thing with item getter. You don't have to assign attribute getter to a variable and then call that variable on the object. You can do that all in one shot if you want to. That's perfectly fine, right? This attribute getter ABC is nothing more than just saying f equals attribute getter ABC and then applying f to my object. Just note the parentheses that I have here to indicate that we're calling, because this attribute getter ABC is returning a callable. So we need to call it. And that will return the tuple 10, 20, 30. We'll see examples of that in the code as well. Now, we can also call another callable. Let's see what I mean by that. So consider the string class. Now, the string class provides a method called upper. That's an attribute as well. So if s is Python, we can say s.upper, and that will return the upper string variant of Python. So in this case, this capitalized Python essentially. Now, upper is an attribute, so we can get a hold of it using attribute getter, just like before, right? But attribute getter is going to return what? It's going to return the attribute upper, which is a method. So f is a callable. Remember, it can't really execute this yet. It's saying, okay, once you pass in the object, I will go and get upper for you. So f is a callable, but when you call f, it's going to return a callable because it's going to return the upper method, but bound to that object. It's going to return the upper method for whatever object you pass to f. So let's see what I mean by that. Let's say we call f of s. S is the string Python. So what are we getting? It's returning the upper method of s, the upper method of Python, but it hasn't called it, right? It's just the method that's being returned. If we actually want to get Python in uppercase out, we still have to call it. So now it can be called using that, just like we did here, right? s.upper without the parentheses is what is being returned by f of s. Now we still have to call it by putting in the empty parentheses. So now we can do it this way, f of s, so that's going to return the upper method, and then we call the method, and then we'll get Python. So that's a little convoluted, right? So there's a better way. I mean, you can write it this way, obviously. You don't have to use this kind of f in between. You can call it this way, but now look, it even gets worse. Attribute getter, upper, s, and that. All it's doing, think of it this way, attribute getter, upper is a partial that will return the upper property, the upper attribute of whatever gets passed in, which is the object. Since upper is a callable, we have to call it in order to call s.upper. And that will return Python as well. So there's a simpler way that the operator module provides us called method caller. There's a method caller function which essentially kind of wraps this up for us. So we would say method caller upper on Python. So we would say call this method. So basically it removes this need to call the method separately. It's saying call this method. The method is going to be called upper, and it's going to be found in whatever object is passed in here. Here I specified a string. String has an upper, so Python has an upper method. So this is going to call the upper method on the object string Python. And that will return Python as well. So it's a lot simpler to use. And we'll see that in the code as well. But it's really just more of a convenience thing. You can definitely do it using attribute getter. That works just fine. It's just a little convoluted. This might be a little simpler. All right. So it can also handle more arguments. We'll see that in the code as well, where we can actually have more than one method being called. And we'll see that because obviously, remember, attribute getter can also get more than one attribute. So we'll see that in the code. So let's switch to code and see all that in action. Thanks for watching, and I'll see you in a bit.